We're going to look at 4.4 today, which is graphs of the sine and cosine functions. Okay, so let's start with f of x equals the sine of x. Okay, if I were to graph this function, and I'm going to graph it from negative 2 pi to positive 2 pi, okay, this function's going to start here. It's going to go up to positive 1 and down to negative 1. Okay, same thing on the negative side. Okay, so the graph of a sine function looks like this. Okay, it's a periodic function. It makes waves. And we looked at this during our 12 basic functions. Okay, so this is in your textbook. It's the first page of 4.4, right? So we have the function f of x equals sine of x. This is called the sine function. The domain is negative infinity to positive infinity. It goes on and on forever. Okay, the range is negative 1 to positive 1. It just keeps fluctuating between positive 1 and negative 1. It's continuous. Okay, it increases and then it decreases and then increases and then decreases. It's symmetric with respect to the origin, so this is an odd function. It is bounded. It's bounded above and it's bounded below, right? It's bounded above by positive 1. It's bounded below by negative 1. It has a max of positive 1, a min of negative 1. No asymptotes. And it doesn't have end behavior because this function is periodic. It oscillates between negative 1 and positive 1. Okay, so there's no end behavior on this function. Okay, the cosine function is very similar. Okay, and I'm going to graph the same on this one. I'm going to go from negative 2 pi to positive 2 pi. Okay, so the sine function crosses the origin at 0, 0. Okay, cosine is not going to do that. Cosine is actually going to be up here at positive 1. Okay, however, it really behaves very similar. Okay, and using transformations, it's actually possible to transform sine into cosine or cosine into sine. All right, so cosine function is also periodic. It's a wave function. Okay, it bounces back and forth between positive 1 and negative 1, and it looks like this. Okay, just like sine when we did our 12 basic functions. Okay, cosine, very, very similar. Domains negative infinity to positive infinity, range negative 1 to positive 1. It's continuous. It alternately increases and decreases. It is symmetric with respect to the y-axis. Okay, so there's a difference. Sine is odd, cosine is even. It is bounded. It's bounded above by positive 1 and below by negative 1. It's got a max of 1, a min of negative 1, no asymptotes, and no end behavior. Okay, So let's talk about some attributes or behaviors of these functions. Okay, so first of all, okay, when we talk about a sinusoid, okay, that's a little hard to read. Let me rewrite that. Okay, that's the function f of x equals a sine bx plus c plus d. Okay, where a, b, c, and d are constants. And a can't be 0, and b can't be 0. Okay, so that's a sinusoid. It's just a sine function, and I'm going to refer to it as the sine function from here on out. Okay, when we talk about amplitude, okay, so the definition of amplitude is half the height of the wave. Okay, when you're looking at the sine function, f of x equals a sine of bx plus c, okay, plus d. The amplitude is the absolute value of a, okay, and it's the same for the cosine function. Okay, so if you come back to these graphs, the amplitude is half the height of the wave. Okay, so since this wave for this function bounces back and forth between -1 and +1, the amplitude is 1, right? So from here to here, the distance from the middle of the graph to the top of the graph is 1, and the distance from the middle of the graph to the bottom graph is 1. Okay, so the amplitude is the distance from the middle to the top, and cosine's the same. Okay, the distance from the middle to the top is 1, the distance from the middle to the bottom is 1. Okay, so let's look at example 1. Okay, find the amplitude of each function and use the language of transformations to describe how the graphs are related. All right, we're going to start with just this basic sine function. Okay, so in this case, okay, remember our standard form is y equals a sine of bx plus c plus d. Okay, we're looking at the number in front of the sine function. If I don't see a number, it's a 1. Okay, so my amplitude, and we just looked at this, of a normal sine function is 1. Okay, let's say we have y equals 1/2 cosine x. Okay, so our amplitude is this number out here in front of the function. Okay, so our amplitude is 1/2. Okay, now we need to describe this in as transformations. Okay, So if we multiply a function, remember, by a number between 0 and 1, that's a vertical compression or a vertical shrink. Okay, if we multiply by a number greater than 1, it's a vertical stretch. So since 1/2 is between 0 and 1, this is called a vertical shrink. Okay, so this graph is vertically shrunk by a factor of 1/2. Okay, let's say that we have y equals -4/3 cosine x. Okay, so again, we are looking at this number, okay, in front of the graph. And if we go back to our definition of amplitude, okay, it says it's the absolute value of that number. Okay, so amplitude is never going to be negative. It's always going to be the positive form or the absolute value of the number in front of the function. Okay, so even though the number in front of the function is -4/3, our amplitude is +4/3. Okay, 4/3 is greater than 1, so this would be a vertical stretch by a factor of 4/3. Okay, the negative sign does not affect whether it's a stretch or a shrink. The negative sign is a reflection. Okay, so this graph is reflected across the x-axis. Okay, so when we have a negative number out in front of that function, the negative tells us it's a reflection. Okay, this number tells us whether it's a stretch or shrink. Okay, last one, y equals -3 sine x. All right, so again, we're looking at the number in front of the function. Okay, the amplitude is always the absolute value of that number because it's the distance. It's half the height of the wave, okay, or of the graph. So in this case, the amplitude is 3. Okay, 3 is greater than 1, so this is a vertical stretch. Okay, this graph is vertically stretched by a factor of 3. And that negative sign tells us that it is reflected across the x-axis.